Hello, this is Samuel Pokoo, a doctoral student of California Intercontinental University, and this is a presentation on conducting a correlation testing. The agenda for this testing include introduction, the 6 correlation tests and their outcomes as part of this week's submission. Then we are going to look at the important takeaways and address any questions that viewers might have. So, introduction, stating the hypothesis. This hypothesis is two-tailed. The null, which represents the fact that there is no correlation between two variables, where R is equal to 0, or the alternate is that there is a correlation between the two variables. R is not equal to 0. The rejection rule is that we will reject the null when the p-value is less than alpha, where alpha is equal to 0.05. However, if the p-value is greater than alpha, we fail to reject the null hypothesis. Correlation is primarily a quantitative estimate of the relationship between two variables, and this is symbolized by R, which ranges from R equals to plus 1.0 for a positive correlation to R equals to minus 1.0 for a negative correlation. The following are the 6 correlation tests and their outcomes with reference to this week's submission. We are going to do tests for the income and savings, income and stocks, savings and stocks, income and wallet, savings and wallet, and stocks and wallet. So we start with our correlation test number 1, income and savings. The following correlation test was conducted. The null hypothesis says there is no correlation between participants' income and their savings. The alternative hypothesis also states that there is a correlation between participants' income and their savings. So the correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged where R is equal to 0.91 and the p-value is equal to 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participants' income and their savings. So following is the correlation, the graphical presentation of the scatter diagram for the income and scatter plot diagram for the income and savings correlation test 1. Correlation test 2 is about income and stocks. The following correlation test was conducted. The null hypothesis states that there is no correlation between the participants' income and their stock valuation position. The alternative hypothesis indicates that there is a correlation between the participant income and their stock valuation position. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged where R is equal to 0.91 and the p-value is equal to 0.018. The test rejected the null hypothesis and concluded there was a correlation between the participants' income and their stock valuation position. Following is the graphical representation of the scatter plot for the income and stock correlation test conducted. Correlation test number 3 is about savings and stocks. The following correlation test was conducted. The null hypothesis says there is no correlation between the participants' savings and stock valuation position. Alternative hypothesis states that there is a correlation between the participants' savings and their stock valuation position. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged where R is 0.20 and the p-value is 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participants' savings and their stock valuation position. Following is the scatter plot diagram for the savings and stock correlation test. Correlation test number 4 is about the savings and wallet. The following correlation test was conducted. Null hypothesis said there is no correlation between the participants' savings and their wallets. Alternative hypothesis states that there is a correlation between the participants' savings and their wallets. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged. R was equal to 0.91 and P is equal to 0.000. The test rejected the null hypothesis and concluded there was a correlation between the participants' savings and their wallets. We showed in this slide the savings and wallet scatter plots. Correlation test number 4, stocks and wallets. The following correlational test was conducted. The null hypothesis said there is no correlation between participant stock position and their wallets. Alternative hypothesis states that there is a correlation between the participant stock position and their wallets. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged. R is equal to 0.19, where P is equal to 0.017. The test rejected the null hypothesis and concluded that there was a correlation between the participant stock position and their wallet. We now show the scatter plot for stocks and their wallet. The last correlation test is number 6, and it talks about a test for income and wallet. The following correlation test was conducted. Null hypothesis states there was no correlation between the participant's income and their wallet. Alternative hypothesis states that there is a correlation between the participant's income and their wallet. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha is equal to 0.05, a significant correlation emerged. R is equal to 1.00, P is equal to 0.000. The test rejected the null hypothesis and concluded that there was a correlation between the participant's income and their wallet. We follow with the scatter plot diagram of participants' income and their wallet. The important takeaways for this presentation include: 1. Correlation provides direction and strength. Correlation is always between -1 and +1, and each scale is independent of the scale of the variables themselves. Correlation is standardized. The PSP is a user-friendly statistical tool that can be used to perform correlation tests. To visually confirm your analysis, use your scatter plot diagram. It is important to flag significant correlations. These are the takeaways. The references used for this presentation are stated in this slide. Any questions? Thanks for granting me audience for this presentation. Thank you. See you another time.